Hi everyone, I'm Master Sergeant Jeremy Neilson, and I'm very excited to be here with you today to discuss what we've been doing at Edwards Air Force Base in relationship to virtual and augmented reality. And specifically, my job for the Air Force is I'm a training manager. So I work with the F-35 maintainers, and my job is to make sure that their aircraft mechanics and all the various subsections that include those are qualified to do their jobs to the best of their ability. So I have a brief presentation that I would like to go over with you, and then I would be welcome to answer any kind of questions that you guys may have on this technology. I'm sure you guys are already very familiar with it in the commercial sector, but it's very exciting for me personally that we're also using this in the DoD. So I'll go ahead and get started on the slides, and we'll go from there. So just so that I know that I covered it, when it comes to the different, I'll call them flavors of virtual and augmented reality technology, there's a couple examples that I wanted to demonstrate to you, and it kind of explain what they are. With augmented reality, it's kind of like wearing a pair of glasses. You can see the real world around you, but you can overlay information or insert information inside of that space. A good example that I'm sure you guys are already familiar with would be like Snapchat, where you use your phone, there's a camera, and you can put overlays on your face for you and your friends. These are some of the examples that I haven't seen actually in execution, but that we're excited to try to pursue on behalf of the DoD when you talk about mixed reality, as in having remote tutors that can give you assistance when you're doing your jobs. In the aircraft mechanic field, we're also looking into that aspect. We have different categories of qualified airmen, and sometimes their supervisors or their managers can't be on site, but if they could do that remotely, it would give them the ability to be effective with ensuring the quality of their work. There's also, I don't know any of you, if you've ever looked at a map, but a 2D image with little roads and you try to interpret what the mountains are and where they are, but using advanced technology, we're trying to enhance our ability to understand things of mountain terrains, if there's emergency responses, fires, hazard spills, earthquakes, things of that nature. There's also ways that you can use this technology if you have static, as in it's not meant to be moved, kind of like a museum. If you have images, you can put information on GPS locator signals that when you come across them and you have the technology to recognize it, it explains that information. And that could be very applicable if you're trying to gather information as you go through a site, or if you're going through, let's call it a hangar in an aircraft, and you need to know where certain things go, that information can be applicable. And hopefully, you guys are using this technology in your classrooms to some capacity, and if you're not, I would imagine you probably will in the years to come in introducing new ways to digest information. Not that there's anything wrong with the way that we've done things up to this point of using text and visuals that are 2D images, but the human brain is meant to experientially learn from your environment around you. And if we can use this technology to enhance those capabilities, then our assumption or our theory is that we can enhance the way that you perceive that information being applicable to your life. So these are some of the examples of technology with augmented reality. The difference between augmented and virtual reality is fully immersive, as in it'll blind you to the real world around you, but I can put you in any kind of environment I see fit. And the value for our military members under this kind of capability is we can more effectively simulate some of the operational environments that they may experience while they're deployed downrange, and we can add physiological stress-related symptoms to the training they're going through to hopefully give them a better grasp on how they respond initially to those situations to be better prepared for it when they actually go downrange. You can have things read off to you when you're doing your studies. I personally find that very valuable. It may be a basic feature, but instead of me having to just read the script on my own, I learn by having it verbally repeated back to me. And so having those kinds of technologies also incorporated in this learning environment is very valuable for us, and I hope that you guys can help us improve that as you move forward. Currently, the way that the aircraft maintainers have to work is, again, they go off of 2D visuals, and that's the bottom left there. It seems pretty complex to me. I don't even know if I could color code that if you asked me to get some colored pencils and draw it in. So using the future aspects of technology, we're trying to give our maintainers the ability to have more effective insight into not only the placement of these mechanical devices that are highly complex, but also understand diagnostically how they fit together as one solid piece and how you can take them apart effectively. So this is just kind of the direction of an example of how we're going. Another variable that we're interested in when it comes to virtual and augmented reality is currently, when we use physical resources, you have to be sent to another location that's either in the United States or overseas to go to a training course or a school to take advantage of those resources that are only available in certain locations. With the advent of augmented and virtual reality, not to say we're going to get rid of those schools, but we're hoping to consolidate the way that these airmen can learn to do their jobs. If you thought of the way that you learn as a basic pyramid of knowledge, comprehension, and then application, instead of doing those steps individually while paying for these members to be at another location which have, food-related costs, lodging-related costs, their manpower, they could be stateside doing their job, but now they can't. They're away from their families. We're trying to consolidate those learning modules so that they can do it remotely from their stateside location and then only go to that other location when they need to actually get qualified using the physical resource. Also, we're hoping to use this technology to create, I guess what I would call it is a digital twin of these physical constructs and resources, so that way they have the ability to practice on the virtual and augmented reality versions without having to rely solely on the physical resources, because these things, like everything else, they break. And right now, when they break, we can no longer train using them until we fix it, and then it has recovery time and everything else involved with it. So there are many interesting areas that we can go with this technology. It's not just about virtualization and how that technology is rather new for us to be speaking and using. So that's basically all I had for the slides, and I would love if you guys had any input of what you were interested in and how I can explain anything related to either my job, what the Air Force is doing with virtual reality, or what you guys are currently interested in those kind of fields.
Okay, so we have a few questions. First of all, is what technology do you need to study to get into virtual reality?
So when you say what technology do you need to study, I would say computer science is always a very valuable tool, but shockingly enough, it's not just about the technology itself. Many people in the virtual and augmented reality sphere are also artists, and they're designers. They're very interested in audio and visual design. They need to understand the way that the human eye interprets the world, the way the human ear can sense the world around it. And so coupling the idea of computer science with art gives you the ability to render things that are appealing to the human senses or that are more sensationally related to what we are used to experiencing.
So do you have to use any programming, or do they have to know any programming?
I would say if you're building the software, yes, you would need to know programming, and you would want to go down those fields. There are many different types of programming. I would suggest picking one of the ones that has more of a universal spin-off. In my experience, I've used JavaScript, so that's the one that I'm familiar with. I know that people kind of get in wars of whether they like C# or JavaScript or whatever format, but that would be my immediate suggestion. But if you're interested more in the modeling aspect, there isn't necessarily a need to code. It's more related to understanding geometry and basic math to be able to make shapes.
Okay. So you talked about this for aircraft maintenance, for training them. What other areas could it be used for training or for education?
I would love to say that it's limitless. I mean, there are many aspects of, so before I was a training manager, I was security forces, so military police. This could be used inside of those environments to do rehearsal drills, to respond to incidents on base. The firefighters could use it to respond to emergencies or to simulations of such. The CE members, our civil engineers, could use it when they're trying to construct building pipelines or electrical flows. anything that you could think would be valuable in a virtual domain, you could arguably use it for training. The biggest application that you have to, or the biggest caveat you have to consider though is the cost worth the expense of paying for it? Is it as realistic as it could be? Is it educationally relevant? And that's where we have an entire sector that is specialized in identifying what would be educationally relevant versus what is virtualization just for the sake of it.
Understood. Okay. So again, I know you're really geeked about what you do, which is cool. But what is your favorite part then about your job?
The favorite part of my job is to be able to relate to other people's struggles, because as military members, we don't necessarily understand the nuances of other people's jobs until you sit down and you get the chance to listen to what their concerns and what their struggles are. And using this technology, you get the chance to hear them out, to understand it at an in-depth level where you can harness this technology and relate it to an actual pain point that they have with their job. And when you can walk away from that situation and know that they can more effectively support our organization and national defense, that's probably the best part, the best feeling.
Well, then how did you get into this? Let's just start there. Like your story. How did you even, growing up, is this what you wanted to do, or did you just kind of stumble along and fall into this? How did this happen?
I would love to say that I had a plan. I did not. I literally, if you guys have ever heard of Pueblo, Colorado, it's a steel mill town. It's a shut down steel mill town, so we got a Walmart supercenter. We thought we were in New York City, which you know where you're coming from because we say New York City and like you don't know that it's a city. But it definitely wasn't a plan. I joined the military because I was living with my grandparents and they couldn't really afford to take care of me any longer. And throughout my deployments as a military police to Iraq and Afghanistan, I began to appreciate the importance of doing drills and understanding military practices and procedures and knowing how emotions can conflict with your ability to mechanically respond to situations as necessary. And so when I left that career field and got assigned to aircraft maintenance, I saw that they were using PowerPoint slides to do much of their training. And I asked them, is this what you guys want? And they said, no, but this is what we have. And from there, I was able to, under the 412 test wing, get innovation money to pursue this technology and test this use case. And we've shared that with multiple installations at this point. So it's been very rewarding.
Okay. So then you said this was not what you envisioned when you were a kid. What were you thinking as a kid that you were going to be, that you were going to do when you were an adult?
I would love to say I even had a plan. I really liked dinosaurs as a kid, and I enjoy understanding the way that different things work. So I would say if I had a propensity for anything, I'm just very openly curious. And if there was a job where I was allowed to openly be curious and just learn how things worked, that would be great. But I would say this is the closest thing to that. And having an open mind has not only been what I thought was the right solution and getting satisfaction out of believing that to be so and knowing it or proving it, but from being proven wrong and from understanding from others that they have value. Whether we think that we understand it at the same level, you should ask anyone that you can for feedback on your ideas, because they'll always surprise you with what they come up with.
So what has been one of the biggest challenge for you in your career?
I would say the biggest challenge is dealing with the fact that we are all part of societal organizations and hierarchies, and it is your responsibility, not the generation that's going to be retiring before you're in charge, to understand how this stuff works. They have gotten our organization and our country to the level that it is right now, which it may not be perfect, but it's definitely evolved. Mm-hmm. They are not supposed to be the ones who are also then the arbiters of the change that you wish to see. You have to take ownership of those things and work within the construct to make it so. And if that means being patient and doing what you need to keep your dream alive, but also realizing that maybe now is not the exact time to make it so, then that is what it is. And I would say that has been the most challenging part for me but it's also the most rewarding part, because when you start to see everyone that you interact with, whether they agree with you or not, as a chance to verify your ideas and to collaborate with others, because they obviously have an opinion, and it would be valuable to you to know what that is. You gain different perspectives on the situation, and it refines your ability to have a solution that works for everybody.
Okay. So of the different projects that you've worked on, which one has been like the most exciting?
Definitely the first one. Aircraft maintenance has definitely been the most exciting one, and I'm not mechanically minded at all, so that's kind of the irony of the situation. It's basically like they're elementalists that make electricity and cold and hot work on a mechanical machine, and then it defies gravity by flying. So it's been very exciting to be able to understand it to their level, and then to see the passion in these maintainers' aspects on how they look at the things that they work on and the pride they take in, because it's not easy. It's a struggle to maintain these aircrafts, but when they see it fly and they know that it's because of them, they get fulfillment from that. And that's different than happiness.
Cool. All right. So like going back to your childhood, like were there certain classes that were like really tough for you? Which ones were those? Or which ones came the easiest for you?
So I would say math was probably a class that I didn't really need to pay attention to. It came to me fairly easy. It's very rational, you know. You just understand the formula, you plug in the variable once you find out what it is, and you determine what the end state is. I really struggled in my younger years, I'll say like second grade, my teacher had suggested that I be held back because I didn't know how to read or how to spell. And all I remember from those years were being taken away when all the other kids would do scholastics. I would be taken away and I would go and draw. And I never really thought about why until at the end of the year, the teacher brought it up to my parents of, we think he should be held back. And I wasn't, and I learned how to spell, and I, of course, learned how to read and all those things. And I've taken that and tried to embody that, to realize that communication on its own is an art. Regardless of all the different technologies we use to speak to each other, we will never understand each other to 100% accuracy. And the fact that we still try and put all these efforts into making that closer and closer, it makes it an art form, because we'll never be perfect.
That is true. That is true. So then to try to, I guess, capture that, you mentioned some of the things that people can study to get into virtual reality, but as these kids are watching, like what should they be working on as far as like skill sets that can kind of help them succeed, whether they go into virtual reality or some other aspect of some other STEM component?
Absolutely. I would say, from my perspective at least, STEM as a whole, it's a celebration of people that are open-minded. It's people that are passionate about understanding to the best of their ability what the right answer can be by using principles of mathematics or physics or chemistry or thermodynamics, all these things that they use to get to that minuscule to umpteenth % accuracy. But the biggest variable that I would say is in the people I've seen successful in STEM is they have an open mind. They don't go into the math class with the assumption of, I have to do this because I want to be this one day. They go into the math class because they're like, this is a way that we understand the world, and I don't exactly get that. And I want to go into this class and understand. Or when they go into their 3D, or they go into their programming class and like, this is the way computers talk. And it's completely different than the way that we do it. But it's still, because it's different doesn't mean that it's wrong. It means that it's different. And we need to understand how that works, and that we built these things that have their own language. And when it comes to the 3D modeling piece, at least for me, I'm not a great artist at all. I would say learn to accept your successes when you get them, because what you envision in your head, it's never going to turn out the perfect way you want. But it's almost like it's a journey. And at the end of that journey, you'll have something that you're at least 80% satisfied with, but don't hold yourself accountable or judge yourself for not making the perfect thing that you thought you were supposed to.
So then how do you even, like that whole process, right? So you're saying you're not an artist and you're working in virtual reality where there's an awful lot of art, right? To bring these new worlds into being. Mm-hmm. How do you bridge that? What is your process? What is your creative process? How do you go through this? And then again, in your head, you know what it's supposed to look like, but maybe your hands aren't cooperating, and so you can't like reproduce it on paper.
So I would say with my process, at least, the first and foremost thing I try to do is I try to create a schema of who it is that I'm trying to understand, as in view it from, if we're talking about maintainers, see what they see when they look at these aircraft or when they're on the flight line, when they're in their operational environment. And what are the things that I think that they would care about or that would need to be enhanced or nuanced? And then from there, go into what are they tasked to focus on? And I try to, instead of assuming that I myself, as in Jeremy, should get the right answer, I try to take on the persona of who would be this person and what would they want to be effective. And that way it gives me that credence of, if you didn't get it right the first time, then you probably need to go back to the source and ask, hey, so I tried to do it this way, this is what ended up happening. What could I do better? What was I missing? And inevitably they're gonna tell you, and you just have that feedback loop from the customer, from the stakeholder, and you get insight into how they look at it. And eventually it just kind of works. And over time, you're able to accelerate or enhance your ability to more quickly change your state to the way that they see things, and you become more receptive.
So how long, I mean, if you had to put like a time frame on it, like from, you're first contacted by, this group and they're like, we want help focusing on training, right? So we need you to create a world for us. Generally speaking, from beginning, first contact until finished product, how long does that take?
So that answer is codependent upon how many friends you have that are familiar with the technology, because it definitely just doesn't rely on one person. But I would say a safe bet for the first few times that you're doing it, and when you say create a world, you can put a world and put 3D objects in it, but that doesn't make it your home. You have to add the mechanics of the physics of the world. What's the difference in the gravity? What's the lighting? How do these things interact with each other? When do they deflect? Do they collide? And density. So I would say it's highly dependent upon the number of people on your team and then their specialty backgrounds. But that's kind of why it's fun, is if you do have that team, you get that insight on how they make it work. But I haven't really seen something developed in anything less than really 3 to 6 months. Okay. It takes a decent amount of time to create a beta. But the way that we're doing this as a business model now is, at one point we're like, hey, it'll take 5 years and then it'll be great after 5 years. The problem that we're recognizing is, by the time we make that thing 5 years later, it's already outdated. And everything that we made is now irrelevant to the operational environment. So we're learning to accept that it's not going to be perfect and get it done faster and get it to the customer so they can tell us, that's good, but these are the extra things I need. And from there, we want to enhance the way that we create these products, because, I know that we're all pretty consistent with, as Americans, wanting things now, and we're all kind of used to that. But I would say in our business model, we're trying to enhance our ability to get something to you so that we can get that feedback. So it's not a matter of, I'm going to get you the finished thing as soon as possible. I'm going to give you something to then pull out more feedback to build out that image that I'm not understanding yet.
Okay. So what has been like the most surprising thing that you've learned, like in this whole process as you're working with different customer bases? What has surprised you the most as in the whole process?
I would say the thing that has surprised me the most is how going on this kind of an effort, because there's resistance to any kind of incorporation of change. That's just human nature. And I would say the part that surprised me the most is, after going through this experience and try to learn all these things, because I joined the military so I didn't have to keep going to school. But having gone through this experience, and now I have my bachelor's in project management and everything else, and I'm doing all this stuff with virtual and augmented reality, you begin to realize that putting yourself in uncomfortable situations, as in pursuing your education, pursuing a course that maybe you're not that confident you're good at, or a skill that you're not entirely invested in, putting yourself through those situations, it won't be easy, but you'll begin to realize who you actually are. And more often than not, in my experience, you begin to realize you're capable of more than you ever thought you were. And to go back to being sequestered, as in to give up on education, to stop trying to push boundaries and to become part of the next generation of what America needs, you begin to realize that that's so boring in comparison to challenging yourself to be something that you never thought you could be, and then to celebrate that experience with others. And when you fail, you just realize that maybe that wasn't my specific thing, but then you begin to appreciate the people you know that are that thing. Because you're like, I already know I can't do that, but I love that you can. But I would say that would be the most surprising part, because I just hated slideshows for training, and I wanted to make it better for the maintainers. I didn't think that was going to happen.
So do you, I mean, again, we're test wing, right? So innovation is the key. So do you feel like you've kind of captured that with the way you saw this need and then kind of took an out of the box approach to trying to meet it? Or is that something that you continually pursue?
Definitely. To answer the initial question, when it comes to embodying the test wing, I would say that, again, it's a community that embodies something like that. I can, as an individual, have an idea that I think is good, but it only becomes, I'll say, the caliber of the test wing when I solicit feedback from my colleagues and those above me and below me to understand what I'm missing with that equation. And I think that collaboration is what embodies the test wing. I'm just kind of cantankerous sometimes and don't like, simple solutions, I guess.
No, well, own it. That's okay. So what do you think, how would you try to motivate, we got a K through 12 range here. How would you try to motivate them to pursue like the STEM fields?
So I would suggest for all of you guys that are watching this, I can outline to you my experience, but when it comes to the motivation, I would say try this, because you'll realize over time that instead of relying on external entities for your own motivation, you'll begin to have a connectedness with yourself, and even in arduous times or times that you're struggling, that you can appreciate that you are discovering something else. And so when I talk about these technologies, this is where we as a country are going. All of these basically Herculean ideals that we're trying to achieve as a society, as a military, as a country, they require insight into these kind of fundamental skills. And from what I've interacted with, you guys want to make change and you want to make the society better, and you see things that can be improved. And these are the best ways to communicate that in a way that anybody in organizational leadership can understand and get behind. Because these are the universal languages that we use to make things that you want to see happen, the intangible, tangible. And so I can't always guarantee that it'll be exciting, but I can guarantee that when you use these tools, you begin to realize just how awe-inspiring the whole thing is. Existence itself and our role in it as, I'll call it the closest thing to freedom as a country, and to be able to protect the sanctity of those principles. Because AI and machine learning, all these things are very exciting, but they also have questions that we don't have answers to yet. And we need you guys to help us develop the right questions to be able to protect what we care about the most as we move forward and embrace these kinds of innovations.
Okay, so this is kind of going back to your process, right? So you get, I don't know how this works for you, so I'm going to make stuff up, right? So you get a phone call, email, whatever, from somebody saying, I need you to help me do whatever. We're going to train our folks on this tech, on whatever it is we do in this situation. Do they, if it's something that you're not familiar with, do they present you, do you need like just a verbal description? Do they give you a picture? Do they send you a video? Where do you go to base, like, for lack of a better phrase, your first draft? What are you basing that on if it's something you've not seen before and you don't readily have access to it?
Absolutely. That's an excellent question. So it's an amalgamation. Any resources that can be provided are very valuable. But in addition to that, you have to start with the essentials of, under the auspice of training or education, you have to set what are your conditions for learning, what is the behavior that you're trying to achieve, and at what standard are you trying to enforce execution. And so from there, when you guys take tests and you have like, hey, you have to get a 70% or above, this is the topic, and we're gonna talk about these 3 different kinds of modules. That test is designed to test or verify your ability to execute a certain condition and embrace certain behaviors, and then enforce a standard that we as an educational institution have said is valuable. So I create a condition, behavior, and standard matrix, so a list, and then from there, I ask them, can you describe the environment? What tools do they have available? Do these tools have compensatories, as in, do they break after so many turns, or does the weapon jam if they do this so many times? What is the difficulty or the complexity of that you're trying to enhance? And then what are the extraneous factors, as in, my biggest concern with any kind of formal education is it's learning in a vacuum, as in everybody's comfortable, you're sitting down, you have your snacks, but operationally, we all know in the real world, nothing is actually that clean. It doesn't just present itself to us. So then I start to ask about those kind of factors of what kind of distractions do we have in place? Are there any other limitations that the student may have when it comes to impaired vision, or can they not hear, and are those quintessential to their abilities to succeed? And it's interesting because when you go through that process, you begin to appreciate the struggle of their operational environment, and you also begin to appreciate how important it is to get them that exposure and to use the best technology possible to make sure they're prepared. And we not everybody knows, but when you get deployed, there are plenty of things that training cannot prepare you for. But that's kind of the end state goal, is to get them as close as possible to the real thing, so that when they're in combat or they're in a deployed environment, that they can be successful and come home safely.
Awesome. So we have another question. When you're doing the whole modeling, is there a specific software package that you use, or do you use different ones depending on what you're trying to do?
Excellent question. So there are plenty of different kinds of 3D modeling software. Autodesk is very popular, and then they have spin-offs of Autodesk. There's also SolidWorks, which is typically used in educational environments. There's PTC, which is part of a STEM program with the Department of Defense. But there's also, if you guys are just interested in trying it out, there are free versions, and the program that I use for that is called Blender, and you can download it off the internet. There are YouTube videos where they give you tutorials and instructions. You can also go to a website, it's Udemy, and you can pay $20 for basically 60 hours of learning content, and then there's exercises you can go through. But the reason why there's all these different 3D modeling vendors is because they export certain types of models. So there's universal formats of models that are used for different things. And what I mean by that is, if you just want to visualize a cloud, then you don't need to know measurements of that cloud. You don't need to know the density of it in the simulated environment. You don't need it to interact with anything. You just need it to be a cloud. And so you would use a format like an OBJ. It's just a visual file that you render. If you want it to be, if you want to add the extra variables that make it engineeringly sound, like as in density, there's breakage factors, exposure to heat, it responds in different ways, then you want to make a step file. And there's all kinds of FBX and all these different formats. But when you start to ask yourself which modeling software you want to use, you want to ask first, what am I using it for? Am I trying to build a schematic for an engine, or am I trying to make a treehouse? And depending upon your answer to that question, either one can work. They all can make each other's formats, but they do have specialties, as in they're better suited for the various designs. But those were the lists: Autodesk, PTC, SolidWorks, and then the free one is Blender.
So would you say that of those different modeling packages, some are designed maybe for more, I guess, exact dimensions, as opposed to maybe for just creative license? Like if you're going to take the whole creative and it's all about the art, as opposed to the hardcore engineering, no, it has to be exactly this size.
Yes, and thank you so much for helping me out with that. You are absolutely correct. So that's the difference that I was trying to communicate is if you're building for art's sake or for self-expression, then you would use a certain type of program to do that, and it doesn't need to be exact in its measurements. Its geometry doesn't need to be precise, and it doesn't need to have these extraneous data variables, as in if it collides with something else, does it break or does it shatter the other thing, or can you bend it, or does it melt? It doesn't, all that stuff is irrelevant because you're just doing it for artistic expression. But if you're looking for something of an environment that's a simulation of the real world, then you do need to work on a program that has those. You can start with either one. Blender's user interface is difficult to understand because there's so many things you can do. It's not just push this button to do this. It's always hold shift and control down and then scroll backwards and maybe like look at it with one eye and then it'll do what you want.
Awesome.
And I'm kidding about the last part. But it's almost limitless, the things that you can do in a 3D modeling environment. And I would say that's the biggest reason why people are hesitant to get started. But there's nothing wrong if you start with making a cube and making 4 colors, and then you have a Rubik's Cube. Start with simple things, and then from there you can learn to mess with the lighting, to change the density of it, and it becomes a game after a while.
Okay. So we have another question. Again, this is from Miss Valencia's class. So I think I gave y'all a shout out yesterday. So thank you for coming back to us. Hey. So they were basically saying that, they appreciate you sharing some of the struggles that you had when you were younger. Mm-hmm. But what would you do for students? What would you recommend for students who are also experiencing kind of, struggles like that, or at least the perception that they're struggling, mm-hmm. even if it's not real, right? And how would you help them to kind of move through that, past that, and then also get into, like the math and science fields?
Yeah, that's a great question. And I appreciate those of you interested in that answer for being brave enough to ask. And I'm not saying that I do this perfectly, but the best advice that I can give others that are, it's always difficult to follow your own advice, is don't judge yourself. Meet yourself where you are and acknowledge that. And then go from there and say, okay, I know this is where I'm at, and I will take the incremental steps, the investment in me to get to where I want to be. And don't do it because the teacher said so, or your parents or society said so, because those motivations will come and they'll go based upon your relationship with that person. Do it for yourself because there's some reason why you want to achieve these things. And when you find that reason, you'll never lose your motivation, as in permanently, because at the end of the day, the person that you want to be is always waiting for you to meet them, in your future. And by not judging yourself, you're saving so much time in actually just committing to getting started and to figuring out where you're supposed to fit. And again, I'm not that old, but being 30 years old, I can genuinely say that there's years that I've spent wasting being afraid of figuring out who I was and where I was at in educational spheres or personal spheres or business spheres, whatever the case may be. And when I stopped judging myself and I just tried it and I just acknowledged where I was at without judgment, it made it so much easier just to get where I needed to be. And you'll always be surprised because you're never going to end up where you thought you would, but you'll be better for it because where you are will be a place that you earned, not a place that someone presented to you.
Awesome. All right. Well, with that, I think that was going to be our last question. So great way to close it out. So thanks for joining us, folks, and we'll see you again tomorrow morning at 10 o'clock.
Thanks, guys.